for quartiles, okay, we can use it in terms of interpretation, right? We can use it back to back with percentile, okay. However, we use quartile. The main usage of quartile before is actually to help us in developing box plot, right? So quartiles here is a data set that being divided into 4 equal parts, where each part will contain 25% of the data. Just imagine that you have 100 data, right? Without looking at the value of the data, you're just going to divide it by 25%. Okay, you're going to divide it by 25%. So each part will have the same amount of data, 25% each, right? So just imagine like this, you have one set of data. Okay, let's say you have 1,000, right? Sorry, let's say you have 1,000 data. So you are going in finding quartiles. Usually we're going to start with the middle point, so that we're going to have an equal parts later. So then from this middle point, we're going to divide it also equally for the next for the first one, and then so you will get 4 equal part. So each of this part will have, let's say you have 1,000 data, each of these will have 25%, which is equal to 250 data each, right? You have 250 here, and then another 250 here, so 250 here and 250 here. Right? That is what quartile is. And all of this line, right? All of this line is known as, right? In finding the an equal part here, right? You are going to set 3 quartiles. This is known as Q2, which is quartile number 2. Right? This one is known as Q2. As for this one, the first line here is known as Q1. Right? You have Q1 here. And for this will be Q3. Okay, so right, that is how quartile will find, right? So we have Q1, as I said before. Let's look at Q2 first, right? Is the middle line, also known as a median of the value. And then Q1, the middle value in the first half, right? We look at the first half just now, the middle of the first value, right? And then we have the Q3, which is the middle of the second half of the data. Okay. So using this quartile, right, usually being used in creating a box plot. But we are not going to manually create the box plot, right? We are just going to later, we're going to talk about the component that you should have in the box plot, right? And we are going to talk about how to interpret the box plot, right? But we're not going to learn specifically on how to draw this box plot. So let's look at it directly. Okay. Of course, we have Q1, Q2, Q3. This is the first 3 things that you need to have in creating a box plot. Then you will have another 2 things, right? To create a box plot, you need five things, right? Which is 5 values actually, which is known as 5 numbers summaries. Okay, so we have the first one, right? You should have the minimum value, right, as the tail, the lower tail of this box plot, and then you're going to have Q1, after that Q2, and then Q3, right? This Q1, Q2, 3 is actually this tree, which will be served as the body of the box plot. And lastly, you're going to have maximum value, right, which is the maximum value, right? So by using this 5-number summary, right, we can construct a box plot like this. Okay, so that is how you draw a box plot. But still, this is not the only thing you need to know in a box plot, right? We have one more thing, right, regarding the outliers, right? But we're going to talk more about that later. Currently, now we're just talking about position. So for quartiles, right, when looking at quartiles, the thing that you can say, okay, right, we're just going to use this, right? When you have the value of Q2, right, when you have a value of Q2 of your quartiles, let's just look at this. Okay, example, this is where they have this data, and they find out the Q1, Q2, Q3, and also IQR. Okay, IQR stands for interquartile range, which is a range, right, part of a measure of dispersion, right, a range that can only be found by subtracting between quartiles. Okay, that's why it is called interquartile range. So let's see. So they find out the Q2, which is this, right, the second quartile, right? So the way they find it out, okay, they sort it, and then they find the middle point. This Q2 is actually equal to median, right? So it is the same as finding median. So you find the median of this value, you get 14 as the median, or Q2, and then comparing the first part here, find the middle point, which is from 5 till 13, right? The middle value here, which is 9. And then for Q3, the middle value of the third of this second part here, which is 20. So you have Q1, Q2, Q3. So the minimum value for this data is 5 and the maximum is 50. So try to draw the box plot. This is what you get, right? Q1, Q2, Q3 with minimum and maximum, and IQR is interquartile range. So the maximum quartile is 20, the minimum quartile is 9. You subtract the 2, you'll get 11 as the IQR. So how do you actually interpret, how do you actually read the IQR? No, I mean read the quartile. Okay, we are talking about quartile now. So we know that we know that previously quartile talking about splitting data to 4 parts, right, equally, meaning that all of this, right, from this point to this point, which is the first part, even though it seems like small, this consists this should consist 25% of the data. Okay, and for the second part, which is this one, from this point to this point, should also consists 25% of the data. Even though, as you can see, the space is different, right? We're not talking about the area. We are talking about the number of data that you have within each space. So this is 25%, another 25%, and then 25% here from this point. You have another 25% of the data. And lastly, from this point to this point, from this point to this point, try to give a guess. What is the percentage of data that you have from this point to this point? That is actually far bigger than the first three. The answer is 25%, right? It should have 25%. Doesn't matter how big it is, because by right we are splitting it equally, right? How can it be in different size? Because of the distribution, because of the spreadness of the data, right? So what can you say when you are looking at this, right? We can relate it back to percentile, right? With quartile, we know that this is the 50%, right? 25, 25. So we can say that, okay, so basically, just by looking at this, we can say that half of the data, right? Half of the data that we have is less than 14. How do we know that? Because this 25 plus 25. And we know that the top 25% of our data is from 20 to 50. That is among the things that you can say when looking at quartile. Okay, so I think I hope you're clear on quartile, right? In the next video, we are going to talk about the last measure of position, which is Z-score. Thank you.